And welcome back to the Turd Fur channel. Okay, hey, the video just went black. So this video today is actually continuing our series on thermodynamics, and specifically in this one we're looking at the first law of thermodynamics. Delta U equals Q plus W, and I've already in another video went over what everything in there stands for, but just for a little quick reference, delta U stands for a change, anything delta means change, in internal energy. And again, I've went over what that was in other videos. And that's measured in joules. Q is heat, and it is, of course, measured in joules. And then W is actually work, and it as well is measured in joules. Now, most of the time as we're doing these problems, we're going to do a couple things here. If it's give us a graph, let's kind of go through this a little bit. If you're working in a problem and it's giving you a graph, then usually just work is equal to negative of the area under the curve. Now, I'm saying that, and that's true so long as your graph moves from left to right like this. If you're ever trying to find the work on something and you see a line that's actually going the opposite of that, then your work would end up being a positive at that rate. Q, I'll be honest, most of the time you're going to actually use delta U equals Q plus W, and you're going to actually use this to find Q. So now your question might be, well, okay, well, how are we going to find the change in internal energy? Well, we got a couple of ways of finding delta U. One way that we could kind of go after delta U would be we could actually look at in terms of the equation 3 over 2 N R, and I'll write TF minus TI. But a lot of these problems don't actually give us temperatures. If they give us temperatures, then cool. We can actually find delta U this way. But if you remember in chapter 9, PV is equal to nRT. So a lot of the times what we can actually do is just do it this way. PV, and those are like finals, minus PV initials. We can actually just take a change in our pressure volume, so a product of pressure and volume, and this is actually the slickest way of finding a delta U that I can really even give you right here. And this way you don't even need temperature to work these problems. You also don't have to be given moles. You can ignore that. If you're given a graph like the one here, then we're good to go. So I do not want to change my color scheme. So the first thing I'm going to do is, actually do is get this out of my way. And I'm going to go back and let's just do this. This problem, let's find everything that anybody could ask you to find about a PV diagram. First thing is this. I'm going to find the work done from A to B. Work done to A to B means all I have to do is find the area underneath line AB. Now I get to ignore everything else, so it'll be negative of the area underneath that line. Well, when I do that, let's see, I got to take into account that you have to take into account that there is a triangle here, plus the area underneath that triangle. Again, you have to ignore everything else. I'm just looking at AB. So 1/2 base times height, 4 times, and the height of that triangle would be 3. And I need to add in this small region at the bottom. So again, I'm just taking all the area underneath the line from A to B. And we've done this in other videos. This is not new. Plus, what's this? 1 times 4. And so my work from A to B, let's sit here and see if we can do this. That would be 2 times 3. So we've got 6 plus 4. So I've got negative 10. Now that is actually not the right answer. My units in this graph are ATMs and liters, but I can fix that just by doing this, and I'll do one little correction here, times by 101, technically 101.325. But anyway, I'm just going to keep it kind of rounded. 1,010 joules negative. And so that would be my work from A to B. And again, we've done that in other videos. That's why I'm not taking a whole lot of time to break that down right now. If you're to this point, you should have already watched the other videos. Now for work B to C. Well, when you look at B to C, there is no area underneath. This is what's called isovolumetric. Therefore, no work is done. So the answer is 0. And now work C to A. And work C to A is nothing but the area under the line C to A. Well, in this case, that would be, 1 times 4. So that would be, and notice this, I'm going to write positive 4. And now I'm going to kill you, computer. I'm going to times that by 101. And again, this 101 is just me correcting the units. Technically, it should be 101.325. But I'm just going to leave it at 101, which gives me an answer of positive 404. Now, one more time, why was this one negative, and in this case, positive 404? Well, in this case, the volume has actually decreased, which means work was done on the gas, and thus the positive 104. Now, the very last thing I'm going to do is this. I'm going to say, what was the net work for the entire process? Which means, what is all the work combined in this problem is all I'm getting to, which is going to be negative 1,010, 0, and 404 combined is all that we're going to be looking at in this one. Well, let's see. Subtract 400 from 1,000, 600. So 606. Negative 606 joules. Now, there's also another way. If you want to find the work done in a cycle, all you have to do, if you want work net, like if the problem's being really easy, if you're working a problem that looked like this, and the only thing you needed to know was work net, then all you have to do is this. Find the area. Give me a different color. Work net. If you will find the area inside the enclosed space, that's work net. Now that's handy sometimes. If you were given like some kind of a big, ugly looking question, and it does like, and it said find work net, you really wouldn't have to go and find every single work in the problem. You could literally just find for work net the area of the enclosed space, and as long as it's going this way, in other words, it's moving left to right across the top here like this, then it's still going to be equal to a negative answer. So that's a nice little shortcut, but that's only going to help you find work net. So now let's go back, and I'm going to do this next. I got to find delta U before I can find Q. So here's what I'm going to do next. I'm going to find the change in internal energy, and I'm going to find it between A and B at this point, which would be 3 over 2 PV minus PV. So here we go. PV, 6 times 4 is my PV for this area, or 4 times 6, however you want to look at it. So that would be 4 times 6 minus the initial, which would be 1 times 2. And there is how I can get my answer to this. So this would be 4 times 6, 24. 24 minus 2 is 22. Times 3 over 2, that would be 11. So this is 33, positive 33. And once again, I've got that same little catch. If I was working this in meters cubed, or meters cubed over here and PA's up here, I wouldn't have to do this. But I'm going to actually have to do this again where I times, this is a correction factor, times your answer by 101, and that will get your answer. That will get your answer into the units you're looking for. Times 101. Why am I typing that in a calculator? Good grief. 3,033 joules. So there is my answer for delta U AB. Now, delta U B to C, I'm going to find every one of these delta U's, 3 over 2. And again, it's going to be PV minus PV. So in this case, B to C, it'd be 6 times, or 1 times 6, PV. So 1 times 6 minus the initial PV. 4 times 6, 24. So in the case of this, we've got 6 minus 24. No, excuse me, I have a head cold. 6 minus 24. And so what we've actually got there is 18 in this one. 18 divided by 2 is 9. 9 times 3 is 27. And now what we can actually do is go ahead and take that 27 and once again times it by, I'm typing it in a calculator again. What am I doing? 27, which is equal to negative 27 joules. So there is actually my delta U for this one at this point. All right, now as I continue to move on down the list, this time I've got delta U, and this one will be from C to A, and that's going to be 3 over 2. PV, let's go back to it again. PV minus PV, so that would be 2 minus 6 would be my products. So 2 minus 6, and I feel a sneeze coming. Pardon me. So that would be negative 4 divided by 2 is negative 2, so negative 6. And then once again, timesing it by 101, which I also did there and forgot about it. And that is negative 606 joules. And now I have found all my delta U's. So now if I want to find, and I'll just do this, delta U, and if you're already looking at this problem like, I hate this thing. Well, it's the way you have to work it. To get your delta U net for the entire cycle now, all we have to do, now watch this out. This is going to blow your mind. Are you ready? 3 minus 27 minus 606. If you don't see it yet, check this out. What? Did that just happen? Delta U is 0. Why is my change in internal energy for the cycle? Well, think about it. What if you did the whole 3 over 2 PV, that's an R, PV minus PV for the entire cycle? Well, if you've done a cycle, your initial PV and your final PV are the same PVs. Therefore, there is no change in internal energy. You're right back to the conditions in which you started. And that's all we've proved here. Okay, now I know you're like getting dead. So the last thing, wasn't this a video about delta U equals Q plus W? And we haven't even used it yet? You may finally get to use it. So for every one of these problems, I'm going to actually use this equation now. So delta U AB was 3333. So 3333 equals Q AB plus, now I'm going to find work AB, and that was negative 1010 equals negative 1010. So that means that QAB is actually add 1010 to both sides and then do the algebra. So we've got 4,000. Why am I forgetting that 3? We've got 4,000. Long day. 4,343 joules for my QAB. Now let's do a Q for B2C. And all I have to do is the same thing again. I'll look at my delta U BC, negative 2727, plus my work for that side. My work was 0 for B to C, which means Q B to C is negative 27 joules. Hey, we're getting there. Q, where are we at? C back to A at this point. So my delta U CA was negative 606. My work, now I need to do my work C to A. C to A was positive 404. So now subtract 404 from each side. And now this is interesting. QCA is equal to 1,000 negative. Please notice that negative there. Negative 1,010 joules. This is the longest problem ever. Not really. But anyway, now that's kind of neat. So now let's do this. What would Q net be? Well, I could actually just go through and do this since I've got all my Q's laid out. 43 minus 27 minus 1,010 equals Q net is 606. Positive. You don't know how else I could have found my Q net? Remember, delta U is equal to Q plus W. Delta U, now let's talk about net. Change in internal energy net was 0 equals Q, and then work net was actually negative 606. If you don't remember that, we can scroll right back up here. Work net is negative 606. Therefore, that means Q is, or at least Q net, is positive 606, and congratulations, you have endured it. You have found every question you can be asked about a PV diagram. You've used the first law of thermodynamics. We've done everything. Again, sometimes a problem will actually give you like, it'll give you like you've got 1 mole, and it'll give you a temperature or something. If you've got a diagram like this, you don't need it, because all you need are your pressures and volumes, and you can do everything I just did to find all this information. Huge problems, huge answers. Anyway, peace out. Feliz Navidad.